Hello students, welcome to Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter matter in our surroundings, right? Now let's go for continuing this, and remember this is 7th period of this chapter. In 6th period we learned many processes that are involved in change of physical state of a substance. Recall one by one. First one is melting, second one is boiling, third one is vaporization, fourth one is sublimation, fifth one condensation, and sixth one is freezing or solidification, right? And even we learned a diagram to represent the interconversion of different states of matter, maybe solid to liquid, liquid to gas, gas to solid, gas to liquid, right? Not only this, another very important concept was learned, that is about evaporation. Just recall the definition of evaporation. It is the process of change of physical state of a substance from liquid to gas without liquid reaching its boiling point, right? It is called evaporation. Then what are the factors on which evaporation depends? Let's tell one by one. First one is surface area of the liquid. Second one, temperature of the liquid. And third one, wind speed. And fourth one is humidity. These are the four factors which affect evaporation. Next, after that we have come across the differences between evaporation as well as boiling, which is very important in the examination point of view. You must practice it. Just in that, I'll ask one simple question. We have two phenomena with respect to evaporation and boiling, that is surface phenomena and bulk phenomena. Which is surface phenomena? Yes, evaporation. Why it is so? It is because evaporation takes place only on the surface of the liquid. What about the boiling? It is called bulk phenomena because it takes place in all the regions of the liquid, right? Now let's move on to continue this chapter. Particularly in today's class we are going to focus more on evaporation only, that is evaporation causes cooling. I'll write that. Dear students, now let us come to know how evaporation causes cooling. In yesterday's class only we have come to know that liquid get evaporated at all the temperature. Is it not? Irrespective of any temperature, it get evaporated. I'll give you some of the situation. Suppose you go for taking a nail polish removal. What is that? Yes, it is acetone, right? Assume that you have taken some amount of acetone in your palm. How do you feel? Yes, you feel cold, right? Why? It is because, see, the amount of acetone which is present in our palm will receive will use the energy from our body and get evaporated. Even it takes the heat energy from the surrounding also, it get evaporated. As we lose the heat energy, hence we feel cool. Got it? Not only this, even when you go for taking some amount of petrol or diesel on your palm, you feel cool. See that? It is due to evaporation. So this is one of the example to say evaporation causes cooling. Similarly, after sunny day, that is particularly in the evening, we will go for sprinkling the water on the ground, or we pour the water on the terrace. Why? Only to keep that particular area cool. How it happens? So we know that in sunny day, obviously the earth gets heat up. Then by sprinkling the water, what happens? This water will use the heat from the surrounding as well as from the ground and get evaporated, as the ground lost some amount of heat energy and also the surrounding has lost some amount of heat energy. So we feel cool. Got it? Or we experience that cooling. So there also evaporation is responsible. I'll give you one more example. Assume that there is a source of water, and when you stand in front of source of water, how do you feel? Again, we feel cool. Why it happens so? We know that liquid will be evaporating at all the temperatures, and whatever the source of water will be there, it is getting evaporated by taking the heat from the surroundings. As the surrounding will lose the heat, so we feel cool. Likewise, we can give plenty of examples to say evaporation causes cooling. So now I'll write the examples for these and also with the explanation. Yes, I have written the examples with respect to evaporation causes cooling. I have already explained. The same examples are written. See that an open source of water keeps the surrounding cool. Reason: in an open source of water, liquid keeps on evaporating. The particles of the liquid, nothing but water, absorb the energy from the surrounding to regain the energy during evaporation. So this absorption of the energy from the surrounding make the surroundings cool. Clear? And second one, when we take acetone on our palm, we feel cool. The reason is the particles of the acetone gain the energy from our body as well as the surroundings and get evaporated. So as the surrounding as well as we lost the energy, so this causes the palm to feel cool. And one more, after hot sunny day, people sprinkle water on the roof or open ground. See, when we sprinkle water on the open ground, then some of the particles of water gain the energy from that hot ground as well as surroundings, and they get evaporated. As the ground and surrounding lost the heat energy, so this helps to cool the hot surface. Clear? So I'll go for giving you some more examples. Now please go for writing from there to here. Dear students, now I'll give you some more example. In general, during summer day, we prefer to drink cold water, right? And particularly the water which is kept in the earthen pot will be cold. Do you know the reason for this? How the evaporation causes cooling in this case? See, here I am going to take the earthen pot. See, this is earthen pot, and do remember on the surface of earthen pot there will be small holes. Tiny holes will be there all around. Then we have taken some amount of water in it, and when we use it after some time, we feel it is cold. Why? The reason is, look here, as I said, in the earthen pot there will be tiny holes. In that, water will be present, and these water droplets get evaporated to the surroundings by taking the heat energy from the water which is present inside. Clear? As the water present in the earthen pot lose the heat, it becomes cool. Clear? This is one example. And another example, usually in summer day we prefer to wear cotton cloths, right? By wearing cotton cloths, we feel cool. What is the reason for this? How it makes us to feel cool? Here, we know that cotton cloths, they are the good absorber of water, right? And during summer day, usually we sweat more, and this cotton cloth absorb the sweat, and the sweat get evaporated to the atmosphere using the heat energy from the body as well as the surroundings. As a result of it, we feel cold. Got it? So these two examples will also tell us that evaporation causes cooling. Clear? Now I'll go for writing these two as well. Yeah. Please go through these two examples. Here, Fourth example is water kept in the earthen pot becomes cold. Just I explained that. Earthen pot consists of tiny holes. When water is taken in that, these holes are filled with the water droplets. And these water droplets get evaporated to the atmosphere by taking the heat energy from the water which is taken in the pot. As the water in the earthen pot loses the heat energy, water becomes cold. Clear? And another example, wearing cotton cloths during summer keeps us cool. The reason is, we know that cotton, it is a good absorber of water, and we sweat more during summer, and this cotton cloth helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation by taking the heat energy from the surroundings as well as from our body. As we lose the heat and surrounding also lose some amount of heat energy, which makes us to feel cool. Clear? And dear students, we know that in the air water vapors will be present, right? To show that air consists of even water vapors, we have a simple activity. Now I'll go for explaining that. Before that, please go for copying these two examples as well. Dear students, to show air contains water vapors, we have an activity. To do that, we need some of the materials, simple materials. Assume that a glass cup is taken or a steel cup is taken. In that, you just put some crushed ice cubes. Here we have taken a glass cup. Then leave it for some time, about 4 to 5 minutes. What you can see on the outer surface of the glass cup? Yes, you can notice that there will be water droplets, and this will tell us the air contains water vapors. You all may be thinking that how this is possible. We all know that air, the water vapors that are present in the air will come in contact with this cold glass cup, and when these air particles will come in contact with this, they lose the energy, and after losing the energy, they get converted into water droplets which are settled on the surface. Here water droplets are formed because as the water vapors are present in air. Did you understand? You can just recall the concept that condensation. What is condensation? It is the change of physical state of a substance from gas to liquid. When gas is being converted into liquid, then the temperature decreases or not? Yes, it decreases. Here also, when the air come in contact with the outer surface of this glass cup, then these particles will lose the energy. As water vapors are present in that, they get converted into water droplets. Clear? Yes, please go for writing the side heading. Now I will go for writing its explanation. Dear students, observe this question, that is activity to show air contains water vapors, can also be asked in another way, like this. Why do we see water droplets on the outer surface of a glass containing ice cold water or crushed ice cubes? Explain with an activity. This was the question asked in the examination. You will have to draw the figure like this and level the parts. We have taken a glass cup, then crushed ice cubes are taken, then you can notice the water droplets after some time. Here is the explanation, like this, point wise. First point, take some ice cold water or crushed ice cubes in a glass cup and leave it undisturbed for about 2 to 3 minutes. Then we observe that water droplets on the outer surface of the glass cup. How they are formed? That explanation is here. This happens as follows. First point, the water vapors are present around the glass cup. Then these vapors come in contact with the cold glass cup and lose the energy and converted into liquid state. Nothing but they condense into liquid, which we see as water droplets. Clear? So from this activity, as water vapors are present in the air, so they get converted into liquid and form as droplets on the surface of the glass cup. So from this activity, we can show that water vapors are present in air. Clear? Yes, please go for copying from there to here. Dear students, now we are going to answer the questions that are given in page number 10, which are blue in color. Even you might have observed them. Please go through that. First one is, why does a desert cooler cool better on hot day? That is particularly in summer day. Dear students, you know that desert cooler, its main purpose is to keep the surroundings cool. How? So for that purpose only, we go for pouring the water in it, such that the water present in it get evaporated by using the surrounding heat. Got it? But why it is more better on a hot day? Dear students, you know that in a hot day, the less number of water vapors will be present in the air, right? Whereas in cold day, nothing but humid. If it is humid day, air is there, there will be more number of water vapors will be present. So that it is very difficult to get the heat energy from the surrounding to make the water present in the desert cooler to get evaporated, right? That is why on a hot day, the amount of water vapors in the air is less. Thus, water present inside the desert cooler get evaporated easily. Got it? By using the heat from the surroundings. That is why desert cooler is much better on hot day. Yeah. Once you go through this, in a desert cooler, the water inside it is made to evaporate. This leads to absorption of the energy from the surroundings, thereby cooling the surroundings. This is very important point. And why it is better on hot day? It is the explanation. On a hot day, the amount of water vapors in the air is less. Thus, water present inside the desert cooler get evaporated by using the more amount of energy from the surroundings. So this makes the surroundings cool. Clear? Yes. Now please go to the second one. How does the water kept in the earthen pot becomes cool during summer? I have already explained it, right? It is answered. The same thing should be copied. What we had written earlier. That is in the part called evaporation causes cooling. And another one. Why does our palm feel cold when we put some acetone or petrol or perfume on it? Right? It is also answered. Anyhow, once I tell that, see that in case of earthen pot, there will be number of pores on its surface, right? And when the water is taken in the earthen pot, and these pores, nothing but small tiny holes, are filled with the water droplets, and these water droplets get evaporated by using by gaining the energy from the water in the earthen pot. As the water in the earthen pot loses the heat energy, so it becomes cool. Clear? Next, second one is, our palm feel cold when we put some acetone, petrol or perfume. See that these are the evaporating substances. At normal temperature only they get evaporated. So here when we take some amount of acetone, petrol or perfume on our palm, then they get evaporated by using the heat energy from our body as well as from the surroundings. As we lose the heat energy, some amount of heat energy from our body, we feel cool. Next, fourth one. Why we are able to sip hot tea or milk faster from a saucer rather than a cup? Look here. Here You are able to answer easily. This is cup and this is saucer. You are going to take that hot tea in a cup and the same amount of hot tea is to be taken in the saucer as well. But we are able to sip hot tea or milk faster in case of saucer than the cup. The reason is, in case of saucer, the tea that we have taken in saucer will get more area for evaporation. Got it? As it gets evaporated faster, then it becomes bit cool. As a result of it, we are able to sip the cup of, so we are able to sip the hot tea easily in case of saucer than the cup. Here least surface area is available, here more surface area is available. Okay, and one more, fifth one, please go through this. What type of cloth should we wear in summer? And even they may ask you the reason why. So in case of summer, the very first thing is we have to use the cotton cloths. I have already given you the reason. What is the reason for that? Cotton cloths, they are the good absorber of water. During summer season, we generally sweat. Then the cotton cloths absorb the sweat on our body, and as it is exposed to the atmosphere, these water vapors get evaporated to the atmosphere by using the heat energy from the surroundings as well as from our body. Hence, it keeps our body cool. Clear? Yes. Now, you are going to copy from there to here. Now, I am going to write the answer for these two as well. Fourth question and fifth question. Till then, copy up to here. Dear students, you have written up to here. Now, I have written answer for both fourth one and fifth one. Please go for copying fourth one question with a reason. Here I have written, hot tea taken on a surface takes more surface area than in the cup. So this increase in the surface area increases the rate of evaporation. As a result of it, hot tea or milk that we have taken in the saucer cool faster on the saucer and we can sip it more comfortably. And fifth one is, what type of cloths should we wear in summer? Cotton cloths, light cotton cloth than the dark cotton cloths. Both we feel comfortable only, but only the thing is, in case of dark cotton cloth, it absorbs the more amount of heat, it will not give out. So hence it is better to go for using light cotton cloths. And the reason I have already given that in the previous questions. Please go through that one. Now copy from fourth one to up to here. Dear students, now we are moving to the last part of this chapter. You all know that so far we have come across three states of matter. One is solid, second one is liquid, and third one is gas. We have two more states of matter. Do you know what are these? Yes, you are right. One is plasma and second one is Bose-Einstein condensate. Where we can see that, listen, here inside the sun, whatever the matter is present inside the sun, it is nothing but plasma. But is it possible to see that even near to us? Like even you might have observed that fluorescent tube. In fluorescent tube, what is the gas which is filled? Generally helium, and even some other gases can also be filled. Not only this, even the neon gas bulb, you might have heard that, and those bulbs are filled with neon gas. So when electricity is passed in them, then what happens? The matter which is present inside it get converted into the fourth state of matter, that is called plasma. But how this plasma is formed? And now let me explain you that plasma, it is the fourth state of matter, which is a mixture of free electrons and ions. Then what are free electrons and what are ions? Look here. Here, just I'll go for giving you a simple example. Suppose, when you go for taking an element called sodium, its atomic number is 11. That means it consists of 11 protons and 11 electrons inside it. And these electrons are 11 electrons are distributed like this. In the first orbit 2 electrons will be there. In the second orbit 8 electrons will be there. Total how many will be there? 11. Now how many are there? 10. Remaining 1 will be in the outermost orbit. And like this, in some of the atoms there will be more than 1 electrons will also be there. Anyhow, the number of electrons in the outermost orbit of an atom or outermost shell of an atom, they are called free electrons. Clear? Then, not only this, even I'll just go for giving you one more example. Chlorine. Atomic number of chlorine is 17. That means there will be 7 protons and 7 electrons inside it. Then in the first orbit there will be 2 electrons, second orbit 8 electrons, 2 plus 8, 10. Remaining 7 electrons will be there in the outermost orbit. How many are there? 7 electrons. And these 7 electrons present in the outermost orbit of an atom of the chlorine are called again free electrons. Then here, in case of sodium, there is only 1 electron. If this sodium atom if it loses 1 electron, then we say that it gets charged, and we call this charged atom as ion. Clear? So as it loses 1 electron, we write Na 1+. It is positively charged ion called cation. Similarly, in case of chlorine, it has 7 electrons, but it is not able to give all the 7 electrons. Hence, it receives the electron. Because the reason is, for if an atom has to attain the stability, there must be 8 electrons in the outermost orbit. Here, how many are there? 7 electrons are there. It needs just 1 only. Hence, it receives the electron. When it receives the electron, again it gets charged, and we call this as again ion. And as it has gained 1 electron, we write it as Cl1-, negatively charged ion. And this negatively charged ion is called anion. Positively charged ion is called cation. And this is an ion. Like this. If there is a mixture of free electrons and ions, then a fourth state of matter is existed, and we call this as plasma. Clear? And whatever the neon gas or helium gas, that is fluorescent tube, I told, when electricity is passed in that, here atoms are broken up. When they are broken, then they lose the electron. When they lose the electron, what happens? They get charged. And these charged atoms, nothing but ions, will mix with the free electrons which are present in the tube or the bulb. And because of this mixture, the fourth state of matter is existed, again which is called plasma. So here, whatever the energy is released from the sun, it is nothing but plasma. In sun also, there will be high temperature. With that high temperature, the atoms are broken and they get charged and they become ions. And these ions will combine with free electrons and form plasma. Did you understand? So now, let me go for writing the explanation about plasma. You just note down the heading. Other two states of matter. One is plasma and second one is Bose-Einstein condensate. Yes, write the side heading. Dear students, here I have written the explanation about plasma. Just I explained that. Plasma is a mixture of free electrons and ions. I've told you what are free electrons and what are ions. Free electrons, they are nothing but the electrons that are present in the outermost orbit of an atom, or the electrons which are very loosely bound to the atom are called free electrons. And ions, it is a charged atom. Next, we know that it is the fourth state of matter and it occurs naturally in the stars, even in the sun as well. The sun and other stars glow, it is because of the plasma present in them. And plasma can also be made on the earth by passing electricity through gases at very low pressure taken in a glass tube. Even I have explained about them by taking the fluorescent tube as well as neon sign bulbs. Now, dear students, we are moving to the fifth state of matter, that is Bose-Einstein condensate. And we must feel very proud because it is this prediction. There was some calculation made on the existence of fifth state of matter by our Indian physicist is Satyendranath Bose. And after that, the existence of fifth state of matter was predicted by another scientist is Albert Einstein. Hence, the name has been given for fifth state of matter is Bose-Einstein condensate. Then what is this? So this state of matter, it is formed by cooling a gas extremely low density. How much? It is 1 by 1 lakh. That means 1 lakh, whatever the density of the normal air is there, that should be divided into 1 lakh times in that one part. So that much low density, about 1 by 1 lakh the density of the normal air to super low temperature. Once you go through that, Bose-Einstein condensate is formed by cooling a gas extremely low density about 1 lakh times the density of the normal air to super low temperature. And just I told you that in 1920, Indian physicist Satyendranath Bose had done some calculations for the existence of fifth state of matter. On the basis of his calculation, Albert Einstein predicted, yes, there is fifth state of matter, and it was experimentally proved by other scientists. For that purpose, even they have got Nobel Prize as well. And these scientists are, one is Eric A. Cornell, and second one is Wolfgang Ketter, and third one is Carl E. Wieman. So they got the Nobel Prize in the year 2001. Got it? And so this is about your chapter. Please copy from there to here. Yes, you might have copied up to here and go for 2 more points which I have already given you. That one is fluorescent tube contains helium gas, right? And neon sign bulb contains neon gas. And you know the color of the tubes depends on the nature of the gas that we use in the tubes. Okay, copy these 2 points. Then after that, we are moving to answer for the questions that are given in exercise. Yes, please go for writing this. Dear students, now we are moving to answer for the exercise questions which are given in the page number 12. The first question I have written. Observe it. Convert the following temperatures to the Celsius scale. Already we have solved many problems. Here we have 2 more. Let's go for that. First one is 293 Kelvin. It should be converted into Celsius. Then what is the relationship between Celsius scale and Kelvin scale? Yes, K equal to C plus 273 or degree Celsius is equal to K minus 273. And here temperature has been given in Kelvin. We can write 293 minus 273. Go for subtracting. 3 minus 3, 0, 9 minus 7, 2, 2 minus 2, 0. So therefore, 293 Kelvin is equal to 20 degrees Celsius. Clear? Yes. Let's move on to B1. 470 Kelvin is given. Same thing. Here degree Celsius is equal to K minus 273 because we are converting Kelvin scale to Celsius, where K, Kelvin scale temperature, is 470 minus 273. Subtract. Here 10 minus 3 is 7, 6 will remain, and 16 minus 7 is 9, 3 will remain, 3 minus 2 is 1, 197. Hence we can write 470 Kelvin is equal to 197 degrees Celsius. Clear? Yes. Let's move on to second one. Convert the following temperatures to the Kelvin scale. Hope that you can do that. You just solve yourself. Pause in the video, solve yourself. Then after that, again, you can go through what I am going to write. Okay? Observe. Here, temperature has been given in Celsius. Should be converted into Kelvin. So, Kelvin is equal to degree Celsius plus 273. Celsius scale temperature is 25 plus 273, which is equal to 5 plus 3 is 8, 2 plus 7 is 9, it is 298. Hence we can write the conclusion as 25 degrees Celsius is equal to 298 Kelvin. Got it? Yes. Now let's move on to another one. It is 373 degrees Celsius. Then K is equal to degree Celsius plus 273, where temperature has been given in Celsius scale is 373 plus 273. Add them. 6, 7 plus 7, 14, carry 1, 4 plus 2, 6, 646. Conclusion, therefore, 373 degrees Celsius is equal to 646 Kelvin. Got it? Yes. Please go for copying both. Dear students, observe the third question. Give reason for the following observations. So we have to give the scientific reasons. In that A, naphthalene balls disappear with time without leaving any solid, right? Say, usually such naphthalene balls will be used in the cupboard, particularly to protect the cloths from the moths, right? And small insects. And when you keep them in the cloth or in the cupboard, you just observe after a few days, it will disappear. Why it happens so? Dear students, you must remember, naphthalene ball, it is a substance which undergoes sublimation. What do you say about it? It is nothing but sublime, and it evaporates faster. Hence, it disappears with the time without leaving any solid. As it is a sublime, so the solid is directly converted into gas without coming into liquid. That is one. Next question. We can get the smell of perfume sitting several meters away. Certainly. We know that perfume, it is one of the highly vaporized substance, and as it is in the form of vapors, it will diffuse faster in the air. As a result of it, even though we are away from several meters away from it, we are able to get the smell of it. Next, I'll go for writing the answer for those. Yes, these are the answer. Naphthalene shows the property of sublimation. Nothing but they are sublime. And evaporation of naphthalene takes place easily. As a result of it, they disappear with the time without leaving any solid. Clear? Next one. And perfume vaporizes very fast and its vapors diffuse in the air easily. That is why we can smell perfume sitting several meters away. Dear students, now go through fourth question. Arrange the following substances in increasing order of force of attraction between the particles with respect to the substances water, sugar and oxygen. See that increasing order, that means smaller to bigger. So first you have to identify the substance in which the force of attraction is least, and very simple to identify because we know that water is a liquid, sugar crystals are solid and oxygen is gas. In which of these cases the intermolecular force is least? It is in case of oxygen. As a result of it, the particles are moving randomly. Then maximum it is in case of sugar because it is a solid. In solid, the particles are held with a greater force of attraction. And water, it is moderate. Therefore, we can arrange them in the increasing order like this. First, intermolecular force is least in oxygen. Then followed by, then it is water. Then after that, it is sugar. So here, the intermolecular force is increasing. Next, go through fifth question. It is, what is the physical state of water at 25 degrees Celsius, 0 degrees Celsius and 100 degrees Celsius? Yes, what do you say? At 25 degrees Celsius, if it is 1 degree Celsius, 2 degrees Celsius, 10, 20, 30, 40 up to 99, it will be in the liquid state only. So here I'll write liquid state. Then what about at 0 degrees Celsius? We know that water at 0 degrees Celsius, it starts becoming the solid, right? It will be in both liquid state as well as solid state. If it is just minus 1 degree Celsius, we would have told that it is in solid. Minus 10, minus 15 degrees Celsius, they are all in solid. But at 0 degrees Celsius, water will be in liquid state as well as solid state. Here I'll write liquid state and solid state. Next, C1, 100 degrees Celsius. You know that you are very familiar with this magnitude. 100 degrees Celsius with respect to water. What is that? It is the boiling point of water. Then what is boiling point? The specific temperature at which liquid start boiling. Then at 100 degrees Celsius, what will be the physical state of water? It is liquid, and at the same time it is also getting converted into vapors, that is in gaseous state. So hence we can write liquid as well as vapor state and vapor state. Clear? Please go for copying from there to here. Dear students, please go through sixth one. Give reasons to justify. Okay, we know that water at room temperature is a liquid, no doubt at all. But we have to give the justification for this, why it is liquid. Let's go for answering. A. Water at room temperature is liquid. Then just recall some of the important properties of liquid. Whether liquid can flow easily, of course, hence we can call it as fluid, right? Whether it has a definite shape, no definite shape. What about the volume? It has definite volume. So we can write water is a fluid because it has the ability to flow. So liquid have an ability to flow, and liquid have definite volume, and no definite shape. for liquids no definite shape and has no definite shape. See that these are the properties of the liquid. Liquids are fluid, liquids have definite volume but they have no definite shape. So therefore, as water has these properties, we can say that it is a liquid. Clear? Next, B1. An almirah is a solid at room temperature. Then here I'll write almirah. Now, whether it has a ability to flow? No. Then what it is? Whether it is fluid or rigid? It is rigid. We can write is rigid. Of course, even it has a definite volume. Solids have definite volume. And almirah has definite volume. And has definite shape also. See, these are the important properties of solid. Solids are rigid, solids have definite volume, and solids have definite shape. As almirah is a rigid and has definite volume and definite shape, we can call it as a solid. Clear? Yes. Dear students, so far we have answered for 6 questions. We have still 7, 8, 9. Still we have 3 more questions. Let's go for answering these 3 questions. These 3 questions in the next class. And before concluding the class, it's my duty to remind you that whatever we have covered today, please do practice them without fail. Got it? And don't keep anything pending. And another important point is, coming Sunday, we are going to conduct the monthly test. Please get ready, and syllabus regarding this, that information will be sent in the WhatsApp group. Okay? So with this, let us stop the class. Thank you very much.